Hello and welcome. My name is Ben Brownlee for Boris Effect, and in this particle illusion tutorial, we're going to be having fun with forces and deflectors. Now, forces and deflectors are a huge part of customizing up some of the thousands of particle illusion presets and getting them to fit within your own project. It gives you a huge amount of flexibility to make particles look a little bit more organic or to create some more interesting effects as particles interact with backgrounds. So let's have a look at some of the fun that we can have with forces and deflectors. Okay, so within the particle illusion interface, let's find our first emitter. And we're going to start with deflectors. And I'm going to do a little bit of liquid flowing down. So let's come in and find something watery. I'm going to choose water splash, and I've got a couple to choose from. I think water splash 1 that just keeps spitting out water is going to be the way forward. And I'm going to position this up at the top right hand corner, and let's just watch that fall down. There we go. We'll turn off motion blur just to speed this up a little bit. So now we've got our water falling down, looking all right. Let's set up our first deflectors and see what we can do here. I'm going to add a couple of diagonal deflectors. One going top right down to bottom left, and the other one going from top left down to the bottom right, and then sort of falling off there. There we go. And let's see what we get with just the default settings. This is beginning to work a little bit. You know, we can see that the water's hitting our deflector and then falling down, but obviously it stops before it really hits the second deflector. And the reason for that is our splash life is a little bit too short. So if I turn my life up now, you can start to see the particles living long enough for them to come down and go all the way onto the other deflector. Now, what I don't want to do is I don't want to have this up really, really high, because what we're doing there is giving a lot of rendering time or sort of processing time to particles that are way off the screen down here, and we really don't need to see them anymore. So they're still being calculated even though they're off screen. So if I take my life down until the particles are just falling off screen there, so maybe 160 or something. There we go, 167. So now I know that the particle's going to live long enough to be part of the full animation, but they're not going to live too long, or not going to live so long that they're going to be slowing down the whole process and the whole system. And I'm just going to, I've got some splashes coming off here over on this side, so I'm just going to bring my deflector up over there and just reposition that deflector. Still getting a little bit of water falling off over on the edge, but it's not quite as bad. We've still got a leisurely sort of flow down. If I wanted to move these faster, if I just increase the velocity, you can see the velocity is quite high here anyway. So if I just increase the velocity, look what's going to happen to the particles. They're just going to spit out in all directions, which is really not what we want. Unless you want an explosion of water coming at that particular point. And because we're dealing with stuff rolling downhill, if I just increase the weight up here, that's going to give me the results that I want. So all of my particles are going to be affected by gravity that much more. So they're not spraying out as far, and they're also traveling a lot faster. And because they're traveling a lot faster, I could probably come in and take their life down now. So again, we're kind of lightening up the calculations for us. Now, when it comes to how the deflectors are working, let's look at the bottom deflector. I'm just going to tweak this one up to begin with. I sort of don't like how the water's just sort of falling down and then drifting back up there. It's not giving me that kind of excitement that I'm expecting when water's falling. So what I'm going to do with this one is come into bounce and bring my bounce all the way up. And you can see that's given us a little bit more bounce when it hits there. So I'm going to take my bounce really, really high, and let's see what happens with that one. So we've got the bounciness as the water's hitting the second deflector, and that's giving us this really nice kind of clumping going down here rather than just flowing up and then disappearing off again. If I move both of these out the way, or both of these over here a little bit more, maybe make my angle a bit steeper here, we can see that in even better detail. So when we're looking at the bounce on the deflectors, these are calculated as a percentage of the bounce from the emitter, which in turn is being calculated as a percentage of the bounce from the particles themselves. So you can see we've got these layers of bounciness, and it all stems down from the particle. So if the particle's got a big bounce, so we can sort of make the drops have a bigger bounce, maybe not quite as big a bounce as that. We've got all of these multipliers in there, so it's making that really quite large. So in a multi-particle emitter, we can adjust the bounces for each particle individually. Now, the other thing we can do here is try and give this a little bit more depth, because at the moment it looks like we're just seeing this head on. So if I come into my deflector and turn up the thickness, you can see this gives us a little bit more of an angle on our deflections. And I'm going to turn up the thickness really high on the bottom one there. I'll turn off motion blur so we can see this a bit better. So we've got thickness on our deflectors, which helps us to get a bit more of a 3D look about what's happening. The other thing we can do with deflectors is turn down the hit rate on them. So at the moment, our hits are set to 100. So that means that when a particle hits, it's definitely going to be affected by our deflector. If I take this down to 0, it means it's never going to get hit by the deflector. And I think here, if I just want a little bit more kind of natural watery look, I can set my hit rate to maybe 98% on both of these. And this will just show, let's take that back down to 98. So this will just show that some of the particles are going to just fall right the way through. And in this sort of animation, we turn the motion blur on. It kind of, again, sort of reinforces that 3D look where we have water drops kind of bouncing off of our deflector rather than everything being in a sort of flat 2D plane. So even though the particle illusion itself is a 2D particle system, there are a few little tricks you can do to kind of cheat the eye into giving it a little bit more depth. And I'll render this out, and here's our quick experiment of the liquid flowing down. Now we can also use deflectors over objects to create some sort of nice little bouncy effect, or to make it look as if the particles are actually interacting with the background object. In this version of the Particle Illusion Standalone, there is no way of importing background objects or watching background objects. When we look at our composite modes, we can either composite over black, as we are now, or composite over a checkerboard to see the transparency. In the plugin version of Particle Illusion, you can, of course, preview over the source video that you apply the effect to. But there is a little way of cheating to be able to bring in a single image that we can work on. This is the way that I do it. So if I come down to basic, I'm going to use a basic emitter. And this is very basic. In fact, we can hardly see what it's doing. Let's play that through. It's really just, spitting out these basic little blobs. So if I come down to my particle type here and go into properties, I can choose a custom shape image. If I go import shape here, and it's a little PNG called bounce, and it's just text on a transparent background. Let's hit OK on that. And if I go full color, you can see that it is on a transparent background. The original size of this is 1920 by 1080, and this is far too big for a normal particle. Now, when importing any shape, Particle Illusion gives us the choice to scale things down. And this makes a lot of sense. If we've got hundreds of particles floating about all over the place, we don't want them to be, 2048 by 1152 all the time, because that would, completely overwhelm our graphics card. So if I bring this in at just a 512 by 288, and it will scale it in, hit apply on that one there, and apply here, we see I've got my little text being produced by the emitter. So we're going to need to change this up a little bit. Change this to single particle so that it's not trying to create lots and lots of particles for me. And I'm also going to scale this up Now, these parameters don't have units, so what I'm going to do here is just try to scale this up so that it pretty much matches where my original image is. If it's a little bit too big or a bit too small, that's fine for this particular exercise because we're not needing anything to be exact. I can do some scaling when I've rendered it out, but if I had to make a choice, I would err on scaling it up a little bit too big and then scaling it down afterwards in our composite, because downscaling always looks sharper. The only little caveat there is if your particles are going off the edges, is that when you downscale, you're obviously going to see those edges quite a bit. So just have that in mind and try and get it as close as you can. And obviously you can see where this is starting to get a little bit soft. But for what we're doing, that doesn't matter at all, because all we're going to be using this particle for is to see where we can put the deflectors. So I'm just going to create a series of deflectors that just sit over the top of my text. And I'm going to create several different deflectors. And once we've done that, we can rain some particles down over the top of it. So I'll quickly add some pixie dust, animate this over, and let's see what we get. And I'll just play that back. You can see that's now bouncing off my text quite nicely. I can even turn off that placeholder emitter, disable that there. And you can still see that bouncing over the top, which is kind of fun. And I'll just export this out. And now we can start to see how we can use this idea in actual projects. So taking away the placeholders and then just replacing them with something a little bit more interesting. But deflectors aren't the only thing we can have fun with. We can also have a lot of fun with forces too. And here's a couple of ways of using some of our forces. To learn the basics about forces, check out our Understanding Forces and Deflectors tutorial, which takes you through everything you need to know to get up to speed. I'm just going to turn this into edit layout so we've got a bit more space. And I've just got some basic dots. Not really doing anything, not moving at all, just turning a little bit more red over their lifetime, just so we can see what's happening with them. And I've got some forces already set up, and I'll enable these and we'll just have a little quick look through them. Now, with the area backwards one, I've just got a simple area force that's pointing to the right. So all the strength is going to the right-hand side. I'm animating this through our dots. And you can see as the dots get hit by it, they're all going to get some velocity based off of the strength over here in my area box. So if we play that through, what you'll see is everything getting a little bit of a push. And because I've animated the strength of that box from 43 all the way up to 2000 here, you'll see that the dots that get affected last are going to be pushed faster than the ones at the beginning. So we get this nice little look there. Now with this example, I've got this exactly the same box. All I've done is change the direction so that my force is being pushed to the left in exactly the same direction as the area is being animated. And you can see here, this has got some quite interesting little results as it pushes through. Again, we've only got a small amount of push at the start and a large amount of push towards the end. And so these are moving very slowly all the way through, but look what happens when they enter the box again. Whoosh, 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 they're getting that extra little push because our box has still got a strength of 2000. So as soon as these little dots enter into our force, they're going to get an extra little push again. And we wanted to avoid that. Of course, we could just animate the strength back down to 0. If I look at a difference we've got with the grid here, this is the same motion, the same size of area. All I'm doing is I've used a grid box instead. And these are mainly pointing towards the left, but because of the strength variation and the direction variation, some boxes in that grid are moving more to the top and others are moving more to the bottom. So let's see what happens there. So this is kind of an interesting little one because we're getting a bit more of an organic movement, kind of flow moving through there, which I really like. If we do that same experiment one more time, except this time with the grid moving forwards, you get something like an object being pushed away or displacing the dots as it moves through. we can use that, as we've done in this push example, just by animating text through the area where our force is moving. It's kind of interesting. This is what happens when we animate up our grid. So I've got my strength animating from 0 to 200 and then back to 0 again. And our grid is made up of 30 in the X and 28 in the Y. So we have a large amount of cells creating all the variation. That's what gives us a bit more sort of random, less mechanical motion as particles move through different areas on the screen. With our wild force, this is the same kind of idea, except instead of going very gently from 0 to 200, I've animated this negative 1,000 up to 6,000 or 6,500 and then back down to 0 in very, very short order. So let's see what this does. And this is a bit more like a sort of scurrying explosion, which is a kind of an interesting little effect. If I come to our swinging force here and we enable this one, this is just a skinnier force that's just moving around in this sort of way. So that's kind of cool. I like that. That sort of swings around, bats everything around, only as it moves through those areas. So it's a good way of using this to kind of clear an area out. And this works really well when we have quite a high strength. We can take this all the way up to 9,000. Currently it's set to 2,000. Let's see what happens when we hit this on 9,000. We're going to get quite a big result on this. Whoosh. So some of these bigger animated effects do need more extreme strength values to get the particles moving and pushing in the right direction. I'm going to show you one last example here. And this example is going to show you how we can use a grid force, but actually control when the particles start to be affected by it. And this is a little trick you might need to know to have full control over your particles. So we come back to the start, have a little look at this animation. We've just got our basic dots growing up a little bit. And then when they've reached their full size, they start to get blown away by the grid. There we go. But notice on the grid that there is no animation. So how am I animating the velocity of the particles? And that's a very good question. So the speed of the particles is controlled in a few different places. Now, the velocity of the emitter controls the velocity of the particles as they are emitted. And this is a percentage value based on the dots. Notice that this velocity is set to 0. So all the velocity that we're getting is coming from the grid. And we'll have a look in the dots. Have a look at the velocity of the dots themselves. The velocity of the dots are also set to 0. And that doesn't animate at all. So again, all the velocity is coming from the grid. But if all of the velocity is coming from the grid and the grid isn't animated, how have I got my particles staying static while they grow up a little bit here? And this is the secret. The secret is changing velocity over life. So by using velocity over life, as the particles start to grow up, you can see that for the first about the first 20% of their lifespan, they're not going to have any movement at all. And this is the only way to lock stuff in place with forces. Because even if we have velocity set down to 0 in the emitter, velocity set down to 0 in the particle, if the velocity over life of the particle is anything more than 0, then we're always going to be affected by force strength. So to lock particles down, we keyframe up the velocity over life from 0 to wherever we need it to go. So in this case, we've got it going from 0 all the way up to 130 and then back down to 100. So we get a push and then a slowdown over its lifespan. And that's how we can lock particle velocity so they're not being affected by either the emitter settings or by any forces we have on the stage. We've seen other practical uses of forces and deflectors in other parts of this course, and in the future we're going to see more use of forces and deflectors as well. But this exercise has just been about focusing on some of the parameters for forces and deflectors that I think are important and give some interesting and useful effects. We've been working in the standalone version of Particle Illusion up till now. If you're working in the plugin version of Particle Illusion, then it gives you some greater opportunities to interact with your original footage. One of them is simply being able to see what's going on the stage. The other way, of course, is to be able to motion track areas in if you need to. My name is Ben Brownlee for Boris Effects, and I'll see you again in the next part of this Particle Illusion course. Thanks for now. Download Particle Illusion Standalone for free at boriseffects.com. including thousands of free emitter presets. Continue watching this Getting Started tutorial series to learn more about what you can do with Particle Illusion, and find out more about the plugin version of Particle Illusion with extra features, including built-in Mocha motion tracking at boriseffects.com.